War is the ultimate stress test for any kind of technology. You can have all these grand plans and futuristic visions, but the battlefield, well, it has a brutal way of deciding what actually works. Today, we're going to dive into how Russia's entire military AI and software strategy was basically forced to reinvent itself under the incredible pressure of modern war. So, for years, Russia had this sweeping, top-down vision, right? A hyper-connected, AI-driven military. The idea was to create this perfectly synchronized machine where data just flowed from satellites and sensors right down to the soldier on the ground. But, well, the view from the command center and the brutal reality down in the mud turned out to be two very, very different things. So you have to ask, if that big, shiny vision didn't quite pan out, what happened instead? How is Russia actually building its AI-powered military today? The answer, it turns out, is a lot more chaotic, a lot more pragmatic, and in some ways, a lot more instructive than anyone could have predicted. Okay, so let's start by digging into what went wrong with that original plan. The war in Ukraine pretty quickly put a giant spotlight on some really critical flaws in Russia's highly centralized, top-down approach to innovation. Now, the centerpiece of this whole grand plan was something called the Automated Command and Control System, or ACCS. If you're familiar with the U.S. military's jargon, think of it as Russia's version of JAD-2. The goal was to build this one massive, unified digital environment connecting absolutely everything, sensors, commanders, weapons, into a single lightning-fast loop. I mean, an ambitious and powerful idea, at least on paper. And this is where you see the huge disconnect. The grand plan was all about this single, perfect, all-encompassing system built for some theoretical future war. But the battlefield was screaming for something completely different. Small, nimble, specific bits of software that could solve urgent problems right now, not in 10 years. The focus had to shift from perfection to just whatever gave them an edge today. And why did it stall? Well, it wasn't just a technology problem. It was a people and process problem. Russia was relying on these slow, old-school Soviet-era research institutes that were great at building tanks, but agile software, not so much. Developers weren't getting good data. And get this, a lot of it was still being collected on paper. Plus, with so many different groups involved, nobody really owned the problem. So this is where the story takes a really sharp turn. The old institutional system was failing, but a new technology was completely reshaping the battlefield and forcing a whole new kind of innovation from the ground up, and that was drones. The scale of that change is just staggering. 80%. Let that sink in for a second. The vast majority of their artillery and other strikes are now guided by drones. These things went from being a niche capability to the absolute centerpiece of their tactical operations. This wasn't just a new tool, it was a completely new way of fighting. But as you can imagine, this created a new kind of chaos. Suddenly, you had a huge mix of all different kinds of drones, all using different communication channels, all clogging up the airwaves. It was a logistical nightmare. They had all these eyes in the sky, but no effective brain to manage any of it. So what did they do? Well, they improvised. Troops started using commercial, off-the-shelf stuff. They used a hiking app called Alpine Quest for mapping, and believe it or not, they were even using Discord, the gaming chat app, to coordinate drone strikes. But this ad hoc approach created massive security holes, with apps leaking locations and data right to their opponents. And this is where the real pivot happens. With the formal military system struggling and commercial apps proving way too risky, a totally new group of innovators stepped in. A grassroots network of civilian engineers and volunteer coders who just started building the specific, secure tools that soldiers actually needed. And this grassroots effort produced one of the most significant developments in Russia's tactical software, a system designed to create a fast, efficient digital kill chain. Okay, so the system is a complex of different apps all working together. First up, you have Glass. Think of it as the eyes. It runs on the drone operator's controller. Then there's Groza, which is the brain. It receives the coordinates, does all the ballistic calculations, and sends the fire mission to the artillery. And this all sits on top of Zov Maps, which is a domestic mapping platform that gives everyone that shared view of the battlefield. So here's how it works in practice, because it's pretty slick. The drone operator spots a target and just taps it on their screen in the Groza app. Those coordinates are instantly fired off to the Groza hub, which automatically figures out the firing solution and sends it to the artillery. And check this out. If the first shot is off, the drone operator just taps the impact point and a correction is sent instantly. It's a completely seamless digital feedback loop. The crucial impact here is all about time. What used to be this clumsy process of radioing coordinates and manually calculating everything, a process that could take hours, is now squeezed down into just a few minutes. This system fundamentally changes the tempo of the fight at the tactical level. And this same pragmatic, results-driven approach, well, it extends directly to Russia's AI strategy. They are not chasing some far-off vision of a self-aware Skynet. Nope. Instead, they're focused on what AI can do for them on the battlefield right now. Now, this is a very important distinction to make. For Russia, AI is a tool to augment the human commander, not replace them. It's there to help process sensor data faster and maybe offer up some recommendations. But the AI doesn't give the orders, and it certainly does not make the final call. The human is still firmly in the loop. And you can see this focus crystal clear in their development priorities. Their AI for visual and sensor data, things like automatic target recognition and drone feeds, is very mature and ready for the field. But AI for analyzing text, like understanding documents to help with high-level strategy, that's still highly experimental. The reason for this gap really comes down to one thing: ruthless pragmatism. Visual AI gives you an immediate, tangible benefit on the battlefield. It helps you find and hit targets more effectively. That high-level text analysis is a much harder problem with a less immediate payoff, so it gets a lower priority. Simple as that. And here's a final twist for you. To accelerate their development, Russia is heavily reliant on open-source AI models from the West and China. They'll take powerful models like Llama and Mistral, adapt them for military tasks, and then deploy them in their own secure, closed-off systems. It's a hybrid approach that lets them leapfrog years of foundational research. So, what does all of this mean? Russia's wartime journey offers some really powerful lessons for the United States and other Western militaries about innovation, adaptation, and just the nature of modern conflict itself. This quote really is the bottom line. It's not about having the most elegant or complete plan on a PowerPoint slide. It is all about the ruthless, selective application of technology to achieve a real-world effect on the battlefield. That's it. And that leads to some critical lessons. First, success has to be measured by what actually works in the field, not just by grand conceptual plans. Second, you need a wartime-grade data pipeline to learn and adapt fast. It's also crucial to align AI investment with tech that's already mature and operationally ready. And maybe most importantly, you have to open the door for those non-traditional, agile developers, like those volunteer coders, to get involved. Which leaves us with this final question. Russia's story shows this incredible clash between two models of innovation: the slow, deliberate, top-down plan versus fast, messy, bottom-up adaptation. In the future of warfare, which one will ultimately prove more decisive?